Before we look at any code, I want to explain how I want you to think while watching this. I'm not going to explain and then show examples. I want to show you code and ask you to commit to what you think happens next. Not vaguely, not I get the idea. I mean, what is the value right now? Because the CPU never executes intent, and it never executes understanding. It executes instructions, one at a time, and it commits to the result before moving on. If your thinking skips ahead even once, you and the machine are no longer reasoning about the same program. That's what we're fixing today. Reading code feels easy because humans compress automatically. We see patterns and jump to outcomes. We recognize shapes and assume behavior. That works in conversation. It fails in execution. The CPU doesn't know what the code is trying to do. It doesn't know what's coming next. It doesn't even know how the program exists beyond the current instruction. So if you're reasoning globally while the CPU is reasoning locally, you're building confidence on top of a misunderstanding. And that misunderstanding usually doesn't break immediately. It breaks later, when state matters. Pause here. Before that third line runs, I want you to commit to a value. Most people already have an answer. They usually say 10, and they say confidently. If that was your answer, don't change it yet. Hold on to it. That confidence is exactly what hides the mistake. Now let's trace this slow, boring way. The only way execution actually works. The first line runs. X is assigned 0. Stop. At this moment, nothing else has happened. That state is committed. The CPU does not anticipate the next line. Second line runs. The CPU reads the current value 0, adds 1, and stores the result. Stop again. Right now, X is 1. Not heading toward 10, not basically incremented. It is literally 1. Only now does the third line run. The CPU reads the value that exists, 1, multiplies it by 10, and stores the result. Now X is 10. If you're thinking jump to that final value earlier, you skipped 2 committed states. Execution never skipped them. We've already traced it, so nothing here should surprise you. Let's just confirm it. Run the program. There it is, exactly what we traced. The IDE didn't teach us that. Tracing did. This is the mistake, and it's subtle. You didn't misunderstand syntax. You didn't misunderstand arithmetic. You let recognition replace execution. Your brain said, I know this pattern, and moved forward faster than the program could. That works until the skip state matters. And then the bugs feel mysterious, because you never saw it happen. Let's use the same pieces, same variable, same operations. Before tracing, commit again. What's the final value now? If your brain reused the previous answer, that's compression happening again. Trace it. First line runs. X is 0. Second line runs. 0 times 10 is still 0. Nothing dramatic happened, and that's important. Third line runs. 0 plus 1 becomes 1. Same operations, different order. Completely different results. If your order didn't matter, these two programs would have behaved the same. They don't, because execution order is behavior. Again, we're not checking, we're confirming. Run program. Same code pieces, different order, different result. Once you see this enough times, execution order stops feeling optional. This is the rule hiding in both examples. Execution order is not a detail. It is not an implementation choice. Execution order is the program. If you reason symbolically, if you think in outcomes instead of steps, you will eventually write code that looks right and behaves wrong. This is where even experienced developers get sloppy. The comment says normalize value, and your brain wants to believe the story. Pause. Before this line runs, what is X right now? If you don't know, the comment already did damage. The CPU never reads that comment. If X was 0 before this line, multiplying it by 10 preserves 0. Comments describe intent. Execution defines reality. When they disagree, reality wins quietly. This is why these bugs survive reviews. The code looks clean, the narrative sounds right, but the execution was never traced. And untraced execution is invisible execution. Here's the discipline everything points to. If you didn't trace it, you don't know it. One line executes, one state changes. That change is committed. Slow thinking here prevents fast bugs later. Execution is reality, not intent, not comments, not what you meant. If your thinking doesn't follow execution step by step, you're guessing. And guessing is not engineering.